Alrighty, this is the probability unit day 3 notes. We're going to talk about permutations and combinations. Okay, so first the definition of a permutation. A permutation is an arrangement of objects in which order is important. Okay, the factorial. So F-A-C-T-O-R-I-A-L, the factorial of a positive integer n is written as n exclamation point. Okay, so basically a factorial is, for instance, like if I took the factorial of 5, I'm going to start with 5 and go all the way down to 1, multiplying all the integers in between that number and 1. So 5 times 4 times 3 times 2 times 1, right? If I did 6, that would be 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1. Okay, so the number of permutations of a certain number of objects taken are at a time. So we're going to have two things here. N is your number of objects and R is how many of those objects are taken at a time, is denoted by this. The permutation of n objects taken r at a time. So we would take the number of objects, the factorial of that, divided by the number of objects minus the number of times it's taken and the factorial, right? So we're just kind of plugging these into our formula. So here are the steps on your calculator, okay? When you do probability, right? If you go to menu 5, there's an entire menu for probability alone. Okay, so we're going to look at permutations and combinations today. So let's look at a couple of examples of permutations because it's really important that we understand when I'm taking a permutation versus a combination. So you have to ask yourself, is the order important? Okay, Claire and Renee are members of the lacrosse team. If the 20 girls on the team, there's N, are each assigned a jersey number from 1 to 20 at random, what is the probability that Claire's jersey will be 1 and Renee will be 2? So the reason why this is a permutation is because we are looking at two specific spots, right? Two specific spots, okay? So R, yes, is equal to 2. Right? They're taking 2 of these 20 girls, but the reason what makes it permutation is because Claire has to be first, Renee has to be second when it comes to the order of the jersey numbers. Okay, so that is what makes it a permutation. So I'm taking 20p, right? There's N permutation, R is 2. So I'm just going to plug that in. I'm going to take N factorial N, so 20 factorial, over 20 minus 2 factorial, so that's going to be 20 factorial over 18 factorial. Okay, you do not have to do this process, right? This is why we have your calculator steps. So if I enter in menu 5, okay, and I press 2, right? 2 is that permutation option. Let me get the light off of here. Okay, 2. All you have to enter is N, comma, R, right? So I'm going to enter 20. The comma is right down here at the very bottom of your calculator, so comma 2. It will solve this entire formula for you. Okay, so the light, 380. Okay, now that is the number of permutations. Okay, so there's a difference here whenever we're talking about the probability of something happening versus the number of permutations, right? This is just that, right? 380. The chance of this happening is 1 out of 380. So when you're doing permutations, combinations, if it asks you for the number of permutations or the number of combinations, you would simply plug and chug into your formula, there's your answer. But the probability of that occurring, right, this specific event occurring is 1 out of the number of permutations or combinations. Okay? So let's look at example 2. Suppose 6 friends were available. So there's N, right? N is 6. But the photographer wanted only 4 people. So R is 4. We're taking 4 of the 6 people in the picture. What is the number of permutations of 6 friends taking a picture 4 at a time? That is denoted by, 6p4. This number can be computed using factorials. So this is an example of what is the number of permutations, right? So we don't need the probability, we just need the number of permutations. So I would input n factorial up top, 6 factorial over 6 minus 4, which would be 2 factorial. Again, all you need is n and r, and you can use your calculator. Menu 5, 2, okay, n is 6, comma, r is 4. So there's 360 permutations of this specific n and r. Okay, so now let's look at permutations with repetitions. The number of distinguishable permutations of n objects in which one object is repeated r times, another is repeated 2r times, and so on, is this right here. Okay, so again, the formulas, yes, look weird, okay, but let's just look at an example to explain. These are the letters given to you to unscramble and name a U.S. river. Okay, obviously we know it's going to be the Mississippi River. Okay, if you selected a permutations of these letters at random, what is the probability, right? So we're looking at one out of, that they would spell the correct answer of Mississippi. So we have to figure out, well, what is n? N is going to be the total letters, right? Because we're trying to unscramble this word. So there's 11 letters in the word Mississippi. Okay, we're figuring out what's the probability that if we unscramble this, how many permutations, right? Because the order matters here, right? The order of a word matters. That's how I know that this is a probability. I'm sorry, this is a permutation because the order matters. Okay, so R, right? We have a couple of terms that repeat, right? Talking about specific letters. So R1, let's talk about the first letter that repeats, okay? The letter I, it repeats 4 times. Okay, the letter S, it repeats 4 times as well. And the letter P, which would be R3, that repeats 2 times. Okay, so we have 3 letters that repeat. These are going to be our R values. All right, so when I set this up, I have n factorial, which is 11 factorial, over the repetitions, 4 factorial, 4 factorial, 2 factorial. Okay, so when I look at this in my calculator, okay, so you can do repetitions. You can still go to the probability menu, right? But I'm going to do factorials. Let's just do 11. Oh, 1 second. How we have to input it? I have to input 11 first and then do menu 5, 1. That is the factorial of 11. So I'm going to put that down in the numerator. So I have 3, 9, 9, 1, 6, 800. Okay. Let's do 4 factorial. 4 menu 5, 1. 24 times 24, right? That repeats. And then 2 factorial is just 2 times 2, which is 1. So 24 times 24 times 2. So my denominator is equal to 1152. Okay. So if I simplify this, right, 399168800 divided by 1152, I actually get a whole number. Okay. Here is my number of permutations, 34,650. Remember, it's a probability question, right? What is the chance of this happening? Well, there's a 1 out of 34,650 chance that you would unscramble it in the correct order. Okay, so really ultimately knowing that if you have repetitions, you're taking these R values, plugging them in right here, and you're using your factorial setting in your calculator. So you do have to do a little bit of work on this part, right, instead of just inputting it all in the calculator, but you don't have to do each factorial one by one. Okay, the next page. Last example, we're talking about combinations. So a combination is an arrangement of objects in which order is not important. Okay, so a combination of objects in objects, still the total number of objects, taken R at a time, so nothing's changed, is calculated by dividing the number of permutations, right? Here's my permutations. All right. Dividing the number of permutations by the number of arrangements containing the same elements right here. Okay, so all we've done is added this piece to it. But again, with combinations, we can do it in our calculator. We just have to know N and R. All right. Ultimately, the work on your part is to figure out, is the order important, right? Because you can just plug it in your calculator. You don't have to set this up by hand. But I have to distinguish, is it a permutation? Is it a combination? Okay, so we'll talk about the difference between the two examples that we looked at after we solve this one. Monica can invite 6 of her 20 friends. There we go. N is 20, R is 6, okay? But let's read the rest so we figure out, is it a combination? To join her at a theme park. If she chooses to invite friends at random, what is the probability that friends Melissa, Emily, Jack, Tom, Gary, and Tessa are chosen? Okay, so I know it's like, oh, well, she's talking about specific friends, right? But that's fine. We're answering that piece of it with the probability of them coming. But we're not asking, what's the probability if Melissa is chosen first, Emily is chosen second, Jack is chosen third, right? Then we're talking about a specific order of people. But all it says is, what is the probability of those people being chosen, right? I can rearrange these names in any way I want to. That's why it's a combination. So now I'm going to go to my calculator. Menu 5-3 for combinations. N is 20, comma, R is 6. So 38,760. 38,760. But there is a 1 out of 38,760 chance that these 6 friends will be chosen. There was no certain order of the friends being chosen, just those 6 names. Okay, so I could easily turn this question into a permutation question by saying, what is the probability that Jack is chosen first, Gary is chosen second, Melissa is chosen third, Tessa is chosen fourth, Emily is chosen fifth, Tom is chosen sixth, right? That would make it a permutation. But there, like I said, this is a combination because I could rearrange this order any way I wanted to. We're just figuring out the probability that these specific people are going. Okay, so what you want to look out for when you're reading questions, because obviously on your final exam, we're not going to tell you it's a permutation combination. Look at what it's asking. Claire's jersey has to be 1. Renee's jersey has to be 2. That makes it a permutation. Okay?